What are ice donuts? And what role do they have with respect to the ice shelves of Antarctica? Well, Antarctic ice donuts may hold the key to shelf collapse. Hello friends, Jim here. The first direct record of ring fractures in Antarctic ice shows how the phenomenon could cause rapid ice shelf collapse. And here's a photo right here. You see this blue there? That's meltwater. You can see there's a fracture here, more fractures up here. Kind of forms look a little bit of a ring, a circle, hence the term ice donuts. But there it is. This image is the first direct observational evidence of ring fractures forming around a meltwater lake in Antarctica. And one of the researchers, Alison Banwell, took the photo. The Antarctic summer of 2019-2020 was the largest melt season on record for the George VI ice shelf, but things were fouled up because of the pandemic. Alison Banwell, who had placed equipment in November 2019 to record the filling and draining of a meltwater lake, couldn't go. She was finally able to go after 2 years because of the lockdown and so on. And lots of the instrument totally encased in ice. But a time-lapse camera did survive, and it provided first on-the-ground images of ring fractures. These circular cracks in ice shelves have been predicted, simulated, and even observed by satellite. But for the first time, it actually was in situ evidence of that structure. And Banwell is a glaciologist at the University of Colorado Boulder, and they've been working on this problem. In 2013, researchers proposed that ring fractures contributed to the Larsen B breakup. In 2019, they published evidence of ice sheets flexing under the weight of meltwater lakes. Now in the journal Glaciology, they've shared the first direct observations of meltwater lakes leading to ring fractures. So what are the mechanisms? What are the mechanics of ring fractures? Pretty straightforward. As meltwater pools in low points, you have that weight pushing down on the ice. The lakes can grow gradually, but they can also drain quickly, especially if you've got cracks and fissures, from the ice stretching and, that kind of stuff. If the water punches through to the ocean below and drains, the ice shelf rebounds rapidly because you remove the weights. It's like it flexes upward, like a spring. And when it rebounds rapidly, there are fractures that can occur in the process. That can set off a chain reaction. New ring fractures drain nearby lakes, which trigger further fractures, and eventually these fractures can actually shatter the ice shelf. And this process may have caused the rapid shattering of the Larsen B ice shelf, a 12,000-year-old slab the size of Rhode Island that disintegrated in just 35 days in 2002. The most important fracture in Larsen B was this ring fracture. So the newly published images of the ring fractures comes from a dole line on the George VI ice shelf attached to the Antarctic Peninsula. Dolines are drained lake basins that look like massive ice donuts with uplifted rims circling a central depression. As the air temperature warms, the doline fills with meltwater. Meltwater ponding is unpredictable, but satellite records showed that this bowl-shaped doline persisted through several melt seasons. And, serendipitously, it was close to the BAS, the British Antarctic Survey's remote field station on Fossil Bluff. So they went, tutoring around on snow machines. In Alaska, we call them snow machines, not snowmobiles, to put their monitoring equipment in place and so on and so forth. And so they had camera, GPS, temperature gauge, pressure sensors, right? Figure out the volume, temperature, etc., etc. Get all sorts of data and parameters. They returned 2 years later, and when they salvaged the 2 GPS stations, the camera was able to snap images every 30 minutes for the first 4.5 months or so. And those images showed the melting started in early December 2019. Remember, this is Southern Hemisphere, so that's getting into this summer season. Ring fractures appeared by late December, framing the banks of the lake. Antarctica's melting ice shelves can indirectly lead to sea level rise. Well, I say directly, they snap off and get into the oceanic system and be brought northward where they melt. I say they directly lead to sea level rise. But simulations of future collapse are needed to know where, when, and how much melting will occur. Okay, fair enough. The new images improved the understanding of the ice processes. On the ice, observations are essential for simulating ice shelf stability, said Amber Leeson, who's a glaciologist at Lancaster University in the UK, not involved in this research. Though satellites have recorded ring fractures in the past, you really need real-world ground truth examples to constrain the modeling, she said. This study illuminates the timeline and the magnitude of change that can't be fully captured by satellites. It helps modelers make predictions based on the best possible understanding of ice physics. Though most of the research equipment was lost, the study still provides relevant, useful data, said Lauren Andrews, a glaciologist at NASA Goddard Space Flight Center, also not involved. And here's a simulation of what happened to the Larsen B ice shelf in 2002. It's kind of like blew out. This is a really nice example of how straightforward observations can provide insight into ice processes. There is some work remaining, of course. The relatively stable George VI ice shelf is wedged between 2 landforms. The process may be different on less constrained sheets, such as Larsen B. What is clear is that when meltwater lakes form, ring fractures can follow, and ring fractures can lead to shattering, which can break apart the ice shelves. So we get hundreds of these ring fractures can cause a collapse. And she predicted this over 10 years ago. So it's quite possibly a plausible explanation. So you couple that with warm oceanic water melting the ice from below, and now we have a mechanism. We said, well, warmer air temperatures helps melt the ice. Well, now we have a mechanism. It melts the ice, but then we get these meltwater ponds that then the increased weight of the water can push through the ice, causing a rebound, causing a fracturing. So there's a possible mechanism for how warming air temperatures are involved in the loss of ice sheets, which is occurring on the Antarctic continent. And when the ice breaks off, it moves northwards, equatorward, where the warmer ocean waters melted, so it does lead to sea level rise directly. So I thought this was interesting. Wanted to share that with you. Thanks for listening.